We're working on the lab two kinds of friction. We're comparing kinetic friction to static friction. Static friction is the friction between two objects that are not moving relative to each other. And kinetic friction is when at least one of the objects is in motion. We're also going to contemplate what is helpful friction and what is harmful friction. The very first thing you were asked to do as far as equipment goes was you had to get yourself a milk jug or any kind of similar jug and create a chain of rubber bands like a leash on that jug. You were asked to put some water into the jug to give the jug a little bit of weight. In the very first portion of the lab, you are asked to compare how much force is required to overcome static friction when the jug is not moving relative to the countertop, and think about how much force is required to keep the jug moving, which would be the kinetic friction. So here we go. I'm going to start to pull on the jug and I'm going to observe how much the rubber bands stretch and just have a feel for how much force I'm exerting on this jug. And I notice something immediately. Right away I can tell the rubber bands stretch a lot as the jug begins to move. They shrink up as the jug continues to move. I'll do it again. What this tells me is it requires more force to overcome static friction than is required to overcome kinetic friction. There's some thoughts about why that is. One thought is you have to overcome the jug's inertia as part of this. But another idea is that there's little rough surfaces on the bottom of the jug and the top of the countertop, and that those little rough surfaces interlock with each other, and you have to actually unhitch those little rough surfaces. But physicists have noted that it requires more force to overcome static friction than it does to overcome kinetic friction. The second part of the lab is you had to change the surface type. And I'm just going to use my rug that I had by the back door. I'm going to put that on the countertop here. And once again, I'm going to put my jug on there. And paying attention to how much force I'm putting on the jug and looking at how much the rubber bands stretch, I'm going to compare the force on a rougher surface to that on a smooth surface. So here we go. Yep, it definitely requires way more force to pull this jug across a rough surface than it did the smooth countertop. Now that I've got the rug here, let's take a second to talk about helpful friction versus harmful friction. If you've ever fallen down on carpeting and had a rug burn, you have experienced harmful friction because your skin got roughed up by the carpeting. Harmful friction could also be if somebody's like twisting your skin, or perhaps the type of friction that occurs in a car engine that wears down parts. Those are all examples of harmful friction. But friction can also be helpful. We all know that if you go out on an icy cold day, if the bottom of your shoes don't have good treads on them, you're more likely to slip. So treads on the bottom of your shoes on an icy surface, that's an example of helpful friction. Also, if you brush your teeth, that friction between the bristles of the toothbrush and your teeth, that would also be an example of helpful friction. That's it.